I realized in that last video I forgot to finish that last problem. Now, the PDF I'll upload of all these worked out pieces, but just in case. Part C was giving you a graph and 2 points upon it. And again, looking for the equation of that line. There's two ways I could approach this one. I happen to notice, and it's all about one of the neat skills as you take more and more math classes is you're just getting better skills at noticing things. And I noticed that that graph crosses at 0, 1, which is a y-intercept. So if you're feeling, like you could take advantage of that, that might be a good thing to notice that that is a y-intercept of 1. So I could just use the slope-intercept form because I have the intercept. And that's pretty cool. Then the slope piece, you just go in and say, all right, this is down 3 over 1 between 2 points. The ratio between any 2 points on a line is sufficient to give you the slope. So I'm going to use that one. Negative 3 over 1 would be just slope of negative 3. So that one's real quick. Nice little gimme. All right. The next, this is really a topic related to factoring. I wanted to get after some of the factoring. So factor each trinomial. Factoring is a means of rewriting these functions. Its purpose is just to write it in a different form because you would notice different things about it. In particular, we notice the zeros would be the roots of this expression. As it is, I know it's a parabola. If I were to graph this expression and if I factor it, it's easier to notice where it would cross the x-axis, or in this case the t-axis, because our input variable is t. So let me take and factor these. These are the easy kind when there's no coefficient with the t squared. You just look at the factors of 12 that add to 8 in the middle. And so the factors of 12, what are we looking at? 12 and 3 and 4. No, it's not going to work. 6 and 2. Oh, there we go. So 6 and 2 are two factors of 12 that add to 8. And we do t plus 6 and t plus 2. This is kind of the nice one. Everybody loves this kind. The next one, b, similar next to it. You find factors negative 6, 1, and they add to negative 5, so you do y minus 6y plus 1. Done. That's the easy kind, leading coefficient of 1. The number multiplied to variables called a coefficient. And one of the things I noticed, I made a point of, I guess it was in only one of the classes, we were talking about this factored form and what the advantage was, and it's just a way of, it's really easy to notice these things called zeros. The zeros are values that you'd plug in that would give you an output of 0. 6 and negative 1 are the zeros in this situation. So here we're looking at 6 and negative 1 as zeros. I'm highlighting them. I'm going to undo it real fast. But those are good things to know where it crosses. Those are x-intercepts. And in factored form, they're good to know. They're easy to find. In the original form, we know it's a parabola facing up. We also know that if we put in 0 in for y, we get out negative 6. Pretty easy to see just by putting 0 in for y in both cases. So there's advantages to how you write things. C is not factorable in the whole numbers or real numbers, so it's because of the plus. Many of us are thinking, oh, it's a difference of squares, but it's just not a difference. It's perfect squares. It's not a difference. For your own benefit, it'd be good to know it is actually 2x plus 5i. Oops, I can't get that I to work. Oh, one more time. 5i, and then 2x minus 5i. So that's a factored form, but it uses imaginary roots. So it doesn't factor in the real numbers, but it's nice to know it's actually really easy to come up with the imaginary roots or the factors as well. So here, all right, that doesn't factor as reals numbers. It is, the thing I want you to notice, this is not a difference. So that's the key that you want to pick up on this one. Okay. Now we're moving on. We want to go down to here. I pulled this up in one of the classes. Here's the trickier kind. What we have is a coefficient that isn't 1 on this, and we're looking for the factors of 2 and the factors of 9 that when we pair them in multiplication and then add them together, we're going to get negative 4. Well, 2w and w is the only way we're going to factor 2. The 9 is 3 and 3 or 9 and 1. You can use negative 3, negative 9, negative 1. You could go through all the combinations you want of how you'd multiply those factors together. So 2 times 3, I put red arrows in there, 1 times 3, add them together. It is not getting anywhere near negative 4, no matter how you work it. So this one is not factorable. with whole numbers. We could do it with fractional factors, but we're going to avoid that for the moment. Come back to that some other time. In E, this one has factors of 2 and 1 and 2 and 1. If you remember in factoring, it's important to note, we did it in both of these cases, the factors of the lead term, the one that's squared, they always go first in your factor pairs into the, okay, so 2w and w are going to go in the front of those parentheses. The factors you pair them with, the other, what's the constant factors, they go added to, or they're within those parentheses, but they're not the lead ones. So what we see over here in E is here's 2 and 1, and so that means 2x and 1x lead the way. If we put 2 times 2 and 1 times 1 and add them, we get 5. Because we multiplied 2 times 2, we don't want to put them in the same, whatever you multiply factors, don't put them in the same parenthesis. They go in separate parentheses. So 2x in that front left factor, the plus 2 is on the other side. And then after that, the only thing left to place is the 1. That's factoring. Then we're going to go over to the last one here, see what we can do. This one's fresh, so kind of roll with the new one. If I choose 3 and 3, or 9 and 1, I can choose negative 8 and 1, negative 4 and 2. Lots of combinations. So, but the idea is we're going to get a multiplicative pair that when you multiply them together, they add to 6 in the middle. So I'm looking for various types of, just kind of exploring. You can do all kinds of different things, but usually sometimes it has to do with how big you want the product to be. If I do 6, a difference of 6, I think I've got something in here. If I do, I'm going to use a different color. 3 and 2, that makes 6, and 3 and negative 4 here. Now notice they're from mutual pairs. You don't jump. The factors always stay together. So what I've done is I've done the 3 times negative 4 is negative 12, and 3 times 2 is 6. That'd give me negative 6. Well, that's an easy fix. I got negative 6 as my sum. All I have to do is change the sum, or change the sign of those. So if I swap the plus and minus, now I get 3 times. I'm going to highlight this so you can kind of see how this works. 3 and negative 4 got paired together, or 3 and positive 4, that's positive 12. And then 3 and negative 2 is negative 6. 12 take away 6 is our positive 6 that we're searching for. So it's all working out. Now, we took, you know, that whatever you have for your leading factor, here's 3 and 3, so 3p and 3p. I multiplied 3 times negative 2, so that first 3 I multiplied by negative 2, so I want to put them in opposite parentheses. It actually doesn't matter because the factors are the same, but it's a good habit to know whatever you multiply, what factors you multiply together go in opposite parentheses. So just keep them as separate. And then the 3 and the negative 4, those are 3, I'm sorry, and the positive 4 got multiplied, so they go in opposite parentheses. That, if you were to, we're undistributing. Factoring is undistributing. This is my approach to these factoring. It's my trick that I use. I'm kind of going on the assumption that you had enough factoring in the past that you have, you get the idea of where we're headed and what we're doing. If you don't, you need more. I'd love to help you out. Okay, so that we're going to call the factoring chunk. And next I'll be diving into the section 2 where you do the calculator and solving quadratics, etc.